Assalamu alaikum dear students, welcome to the lecture of the electronics. In this lecture we will discuss about the operational amplifier as non-inverting amplifier, and in this lecture we will see that how we can give input through non-inverting terminals, and this will amplify. This will just only do one job. The first, if we give input through non-inverting terminals, so this will be input, for example input, and our output will be just amplified. It will not invert it. Okay, there will be no phase change. So we try to solve this diagram. This is our resistor R1, and this terminal is grounded, so potential of this will be 0, and this is our non-inverting terminal and potential, and here we will give some input voltage. This is our feedback resistor through which we want to gain or extract output voltage. This is output voltage. So let's see what is the current entering to the circuit. Current entering to circuit. So current entering to circuit, for example, let's say this is current entering to circuit is equal to I1. Okay, current through resistance R1. Current through resistance R1. I1 will be equal to difference of potential between these two terminals. Potential difference, and divided by resistance. So I1 will be equal to potential difference divided by resistance, just like Ohm law. So potential difference between these, this is the grounded, so 0 minus V minus divided by R1, so it will be equal to minus V minus divided by R1, and in the second, I2, current through resistance 2, current through resistance 2 will be equal to I2, which is equal to potential difference divided by that resistance. So potential difference will be equal to potential difference of between this terminal and this terminal, so it will be equal to V minus V output over R2. This is the first, V minus inverting terminal minus this terminal potential divided by R2. So it will be V. You know that V minus is equal to V plus V minus, as we already discussed. V plus V minus is equal to V minus, and which is virtually grounded. So V minus and V minus is equal to V plus, and V plus in this case is V input. So V minus will be equal to just like V input. In this you are looking at V minus is equal to V plus, and V plus is equal to V input. So we can write this expression: I2 will be equal to V minus will be V plus minus V output divided by R2. Here we just we can see that V minus is equal to V plus. Why? Because we know that the open loop gain of this operational amplifier is very high, which was equal to V plus V output divided by difference of input, and this was equal to almost 10 power 5, which is a very larger number. So if this is very larger number, so this should be very low. So what is the minimum value of this? The minimum value of this is V plus minus V, which is equal to 0, and if we rearrange this, so V plus will be equal to V minus, and V plus and V minus will be have equal sign. V plus and V minus will be have equal magnitude, and in this case V minus is equal to V plus, and V plus is equal to V input, because we are giving the input at this point. V input will be equal to V plus, and so we have written V plus minus V out divided by R2. So this is I2 and this is I1. So this we can write this is minus V input over R1, because you see that V plus is equal to V minus, and V plus is equal to V input. So V minus can be written as V plus, which is equal to V input over R1. So here V plus minus V out divided by R2, and this can be further written as V input minus V output divided by R2. So we can equalize this. Let this is equation 1 and this is equation 2. Okay, so V input minus V output over R2. If we insert another page of I1, what we obtained is I1, which is equal to V input divided by R1, and I2 we obtained is V input minus V output divided by R2. So according to Kirchhoff law, current I1 should be equal to I2. So V input over R1 is equal to V input minus V output divided by R2. If we rearrange this equation, so V input over R1 will be equal to V input over R1 minus V output over R2. So, and this, I think this, there was a minus sign with this. If we look back, yes, there was this minus sign, so we have to place this minus sign. So V minus, and if this term goes on the other side, this term only goes on the other side, and this term on the left side, so this will become V input over R1 plus V input divided by R2, which should be equal to V output over R2, and we take LCM, so this V output over V input, which will be equal to 1 plus R2 over R1, and here we can see that the ratio of output to input voltage is equal to 1 plus R2 over R1. There is no negative sign in this expression. This shows that this the ratio of output and input voltage will be same. So like V output, both will have same sign. So if we have input like this, so output will be just amplified. There will be no inversion because output over input has the same sign. So our input will be just amplified, and it depends upon the ratio of R2 and R1 plus this one. If we put R2 is equal to 0, it means output over input will be equal to 1, and similarly if we change the R1, our output will be affected. If we increase the R2, so output will be also affected. So we can say simply that the amplification of this operational amplifier depend upon the resistance 2 and resistance 1, and it does not depend upon the internal structure of operational amplifier.